Alright, today we're going to look at section 3.1 and we're going to start with a handout that will look very familiar to some of you. It is the same handout that we had in the last term, but we're going to go over it again because we've got some new people with us. First of all, we have what is a relation. Relation is a set of ordered pairs. And then a function is something, and therefore set of. A function is a relation, and therefore, since it is a relation, it's a set of ordered pairs. But it's a particular set. Relation is like the big umbrella group, and then a part of that are the functions, and the functions are those relations in which each x is paired with only one y value. So the normal way that we look at ordered pairs is like this. So every x is paired with one and only one y. Now, there are several different ways of describing a function, and so we're going to look at those. Hold on, I didn't get the right page. Let me grab another page. Alright, so one option for describing a function is what we call a list or a roster. And if you'll look on page 206 at example 3, this is what it looks like to make a list or a roster. You're just listing the sets of ordered pairs. So you need to write in there something that would help you remember that. Maybe you want to say to look at example 3 or whatever, but it's when you just list out the ordered pairs. Another way for describing it is what's called a mapping, and there's several mappings on page 205. It's when you organize the two sets. It's called the domain and the range. Often it's x and y, but in this case it's not. But it's when you just literally you map. This goes with this. This goes with this. Down at the bottom of that page, there's several mappings. And that's what it means to describe it by mapping. Then you could describe it by a graph. Well, you know what graphs look like. It could look like this. It could look like this. So some sort of a graph. And then, of course, you could have equations. Just equations. I'm looking on page 209. Here's some examples right here that could be functions. So there's 4 different ways that we can describe them. Then we need to know how to determine if it is a function. Well, when it is a list or a roster, you look to see if the x is repeated. So I'm going to put list or roster is x repeated. If it is repeated, it is not a function. So that would imply not a function. If you're looking at a mapping, you're looking for, from the x value, is it paired with 2 different y values? If so, it's not a function. Because to be a function, for every x, there can be only one y value, so that would keep it from being a function. When you're looking at a graph, you look for, does it pass the vertical line test? Vertical line test. And I'll show you what that means more in a little bit. And then you can look at an equation, and we'll talk about that as well. I need you to know that when you see this kind of notation, we call it f of x. It does not mean f times x. It means evaluate the function f for the value that's given in x. And to do that, you first have to be given the function, some sort of an equation that lets you know what the rule is. So then if I said find f of -2, you simply replace the x value with whatever's right here. So that would be 3 times -2 minus 10 would be -16. If you have a function that has more than one x, then when you find f of, say, 2, you substitute 2 in for all the x's. So evaluating a function is really just a substitution process into the rule that you're given. So 4 times 3 is 12, plus 8 minus 5, that's 20 minus 5, so that would be 15. So we would say f of 2 equals 15. And when you evaluate a function, it does generate ordered pairs if that's the desire that you have. So this one would be -2, -16. It means when x is -2, y is -16. This one would be 2, 15. When x is 2, y is 15. So some of us have learned that f of x is really just another name for y. It means find the y when x is 2. And often when we have f of x and we're doing some work, we'll just substitute and replace it with y. All right, hang on to this paper. We'll come back to composition of functions later, but I think that's enough information to get us started to look at a few of the problems. So now I'm going to page 216, and I'm looking at problem number 19, and I'm asked to find the domain and the range and then determine whether or not it's a function. Well, I didn't talk about the domain and range, so let me talk about that first. The domain is the set of first values. Usually that's the set of x's, because typically when we get to the numbers part, we're using x's. In this group, they're not using x's and y's, so we just call it the set of first values. And the range is the set of second values. That is, typically, it's the y values. Well, in this problem, my domain would simply be the list: Elvis, Colleen, Kaylee, and Marissa. My range would be January 8, March 15, and September 17. And so the question is this a function? And you know, this is an example I've used, that one person can only have one birthday. So no person has two different birthdays. Therefore, this is a function. It's okay that two people have the same birthday. So what does that mean? The y value can be repeated. The x value cannot. So we've listed the domain and the range, and we've determined that yes, this one is a function. All right, let's go across to number 20. The father and the daughter. Well, here I see Bob is paired with Beth, and Bob is paired with Diane. one x cannot be paired with two different y values. So this is not a function. You could still talk about the domain and range, which would be Bob, John, and Chuck for the domain. And for the range, Beth, Diane, Linda, and Marcia. Well, look at there. There's my name, even spelled right. So that's the domain, that's the range, but this one is not a function. All right, so here's number 21. Again, we have 20 hours paired with two different salary values. One x with two different y's. No, not a function. The domain would be 20, 30, 40, and the range would be 200, 300, 350, and 425, but it is not a function. Over here on number 22, you see how every x is paired with only one y? So this one is a function. The domain would be this group, the range would be this group, and it is a function. Alright, so those were mappings. Now here's some rosters, or list of rosters where you just write out the ordered pairs. So let's look at number 27 right here. You see I have 3 paired with 3 and 3 paired with 5. That makes it not a function. If the x value is repeated with two different y values, it is not a function. So not a function. The domain you could still do 3, 0, and -4. You don't need to repeat the numbers. And then the range would be 3, 5, 1, and 6. Okay, on this one, I have -1, 0, 2, and 4. So no x is repeated. Therefore, this one is a function. My domain would be -1, 0, 2, 4, and my range would be 8, 3, -1. You don't need to repeat that 3. Let's look at this one. Look at my x values, -2, -1, 0, 1. No x is repeated, so yes, this one is a function. So we know how to look now if it's in a mapping or if it's in a roster to tell whether it's a function. Now, when it's an equation, it's a little more difficult because you have to kind of analyze things. I'm going to write number 31 on my paper. And the question you have to decide is, if I pick some particular value for x, is there any way to get more than one answer for y? Well, think about that. There's not. If I say let x be 5, and I do the math, I'm only going to get one unique answer. Because I can't get two answers, that means, yes, it's a function. Okay? Now we're going to look at number 33. When I pick a value for x, let's say let x be 4, is there any way to get more than one answer for y? No. So yes, it's a function. Alright, now go down to number 35. Alright, you can't see that, so let me move my paper up. Alright, let's suppose that I let x be 4. Well, that would mean 16 equals 8 minus y squared. This is going to be a bad example because I'm going to get a negative number. Okay, that's not a good example for that one. All right, let's let x be 1. All I did was I added y squared to this side to make the equation look like this. So if I let x be 1, that's 1 squared. And then I subtract 1 in order to solve for y. I get y squared equals 7. Well, now you remember when you take a square root, you get both positive and negative. So what I'm saying here is that when I let x be 1, y could be the square root of 7, or it could be the negative square root of 7, according to this. Well, I have 1x paired with 2 different y values, so that makes it not a function. Now, I'm going to give you a little hint. If the equation has a y squared in it, it is not a function, because this kind of thing is going to happen every time. So if there's a y squared in it, that's a really strong clue that it's not a function. All right, let's go on down to number 39. Well, whether you can actually take the cube root of it or not, you only get one answer when you substitute in a value for x. For example, if I let x be, say, 27, well, the cube root of 27 is 3. It's only 3. There's no other choice. Well, what if I let x be 10? Then I get y is the cube root of 10. And although I may not know what the cube root of 10 is, it's still one single answer. So this one is a function. All right. The next group of problems starts with number 43, and there's lots of parts to this one. Find f of 0, find f of 1, find f of negative 1, find f of negative x, find negative f of x, and then there's 3 more. I'll get to those in a minute. So in number 43, my equation is 3x squared plus 2x minus 4. And so what I do is let x be 0 in this equation. So I get 3 times 0 plus 2 times 0 minus 4. That turns out to be negative 4. So f of 0 is negative 4 for this equation. Then I let x be 1. So 3 times 1 squared plus 2 times 1 minus 4. So I have 3 plus 2 minus 4. That's 5 minus 4. That's 1. So f of 1 is 1. All right, that's not going to work to do it sideways. So let me come on down here. F of negative 1. So I take the same equation and I'm replacing x with negative 1. So negative 1 squared is positive 1 times 3. 2 times negative 1. So that's 1 minus 4, so my answer is negative 3. The next part was f of negative x. Now, what that means is replace x with negative x and simplify it. So when I square a negative, I get a positive. So a positive x squared times 3 is 3x squared. 2 times negative x is minus 2x and then minus 4. That's all I can do for that problem because I don't know what x actually is. So that's the best I can do for giving an answer for that one. All right, I'm still on number 43. And I'm on part F. No, I'm not. I'm on part E. which asks us to find negative f of x. This really is not evaluating a function. This is taking a function and multiplying it by negative 1. So when I multiply negative 1 times the equation that I was given, oops, that's a minus 4 right there, minus 4, right, yeah. When I multiply through by negative 1, I get that. So that would be my answer to part E. Part F asks me to find f of x plus 1. So I take the same equation, and this time I'm replacing x with the quantity x plus 1. So I have 3 times x plus 1 squared plus 2 times x plus 1 minus 4. So now you go off to the side and you multiply x plus 1 times x plus 1, because that's how you square x plus 1. You FOIL that out. And when you do that, you're going to get x squared plus 2x plus 1. Now I'm going to distribute this 3. I'm going to distribute this 2. And now I'm going to look for any like terms I combine. I got 3x squared. And I've got a 6x plus 2x, so that'll give me 8x. And I got a 3 plus 2, which is 5. Subtract 4 makes it a 1. So that's my answer for part F of that one. Alright, part G asks me to find f of 2x. So I take the same equation that they were giving me in number 43, and this time I'm going to replace the x with 2x. Well, 2x squared, you square the 2 and you square the x, so that's going to make it 4x squared, and then I'll multiply by the 3. This is going to be a 4x and a minus 4. So that's my answer for part G. And then finally for part H, they want me to find f of x plus h. Same equation, but this time I'm replacing the x's with the quantity x plus h. And by the same token, you come off to the side and multiply x plus h times x plus h. And when you FOIL that out and combine like terms, you're going to have x squared plus 2hx plus h squared. So that becomes 3. This squared is what I just got right there. X squared plus 2hx plus h squared. Now I'm going to go ahead and distribute this 2. Then I'm going to come back and distribute this 3. And I'll look for any terms that I can combine, and there are no like terms in all of that. So all of that is my final answer. Now, some of you may be wondering, why are you doing this? Well, this is supposed to be a preparation for calculus. Remember, this is pre-calculus algebra. So, finding f of x plus h is something that's very important in the calculus course. To us, it looks like, what was all that for? But that's a preparation for those of you that may take calculus later, and that would be your answer there. So in that group of problems, you're going to do the same thing. You just got all those you've got to run through. So I'm going to do another one. This time I'm going to do number 47. And the equation that's given to me is the absolute value of x plus 4. You remember to take the absolute value of something means make it positive. So when I do f of 0, that's 0 plus 4, which is 4. That was part A. Part B, when I do f of 1, that becomes 1 plus 4, which is 5. Part C, when I do f of negative 1, well, the absolute value of negative 1 is positive 1. So positive 1 plus 4, that's 5 again. Part D, I don't know what the absolute value of negative x is because I need to know what x is. So I'm just going to leave my answer like that. It's true that the absolute value of negative x is opposite of absolute value of x. I really don't know which one of those they consider the best form. So if they don't like this one, try this one. Then part E, negative f of x means just take the equation that you have and multiply by negative 1. So we're going to get minus absolute value of x minus 4. Then part F is f of x plus 1. So I'm going to put absolute value of x plus 1 plus 4. And that can't be simplified, so that would be my final answer for that one. Then part G is f of 2x. So I put 2x in the absolute value. It's true that you could pull the 2 out. So either one of those would be equivalent. And I'm not sure which one my math lab would want. I'll have to check on that and let y'all know. Alright, then the last part is f of x plus h. Well, all you can do is put x plus h there, and so that would be the end of that. Okay? Alright. Then we're going to number 49, whose equation is 2x plus 1 over 3x minus 5. Now, I'm not going to do every single part, but I want to do a couple of parts for you. Like when you do f of 1, which is part B, you just put a 1 in both places for the x. So 2 plus 1 is 3, and 3 minus 5 is negative 2, so my answer is negative 3 over 2. Alright, then I want to do part G, which is f of 2x, and again, you just put the 2x in the place of the x. So I get 4x plus 1 over 6x minus 5. And that's all you can do to that. There's no simplifying that can be done. So that's the final answer there. And then finally, part H on this problem, you're just going to put x plus h in the place of the x in both the numerator and the denominator. So you get 2x plus 2h plus 1 over 3x plus 3h minus 5. And don't make the mistake of thinking that you can cancel out these x's or these h's, because remember, you can only cancel when things are in multiplied form. When they're factors, you cancel out common factors. So that's the best you can do with that. Now, there was another handout for this lesson that I hope you printed off. And it looks like this. And it's called Finding the Domain. Well, we've talked about if you're given a map or a roster that you just make the list. The domain is the set of first values, which is usually x. We said that. Now, how do you do it if you're given an equation? How do you find the domain? Well, the domain is all real numbers, meaning you can use anything you want for x, unless there's two conditions that keep it from being all real numbers. One is if there's a variable in the denominator. Okay? If there is a variable in the denominator, that denominator can't be 0. So whatever makes it 0 is not in the domain. The other condition is what if there's a radical, an even root radical, a square root, a fourth root. If there is, the radicand, that's this part right here that's under the radical sign, has to be greater than or equal to 0 because we don't know how to take the square root of negative numbers. Alright, so how does that apply to our problems? I'm back on page 51. No, I'm not. I'm on page 216, and I'm at problem number 51. And it gives me f of x equals negative 5x plus 4. So here's the questions I have to ask. Is there a denominator with a variable, or is there a radical? I see no denominator. I see no radical. Therefore, the domain is all real numbers. Now, you could write it as all real numbers. You could write it in interval notation by doing negative infinity to positive infinity. Next, I'm going to number 53. The equation that I'm given there is x plus 1 over 2x squared plus 8. Alright, I see a denominator with a variable. I need to know, is there a way to make that denominator equal to 0? Because if there is, whatever that x value is can't be in the domain. So I'm going to subtract 8 and divide by 2. And then I'm going to try to take the square root. Well, I can't take the square root of a negative number. And what that means is, if this is not possible, then this is not possible. So if there's no way for the denominator to be 0, then the domain is still all real numbers. Alright, let's go to number 55. Is there a denominator? Yes. Is there a way for that denominator to be 0? Well, let me check it out. Add 16. Take the square root. Yeah, not only is there one way, there's two ways. If x is 4 or if x is negative 4, that denominator is 0. And because we cannot divide by 0, then these two numbers, 4 and negative 4, are not in the domain. So all real numbers except 4 and negative 4. That's my domain. Now, one way to write that is the set of x such that x does not equal 4, x does not equal negative 4. That's one possibility for how you could write that. So if there's a denominator, and if it's possible for the denominator to be 0, then those numbers have to be excluded from the domain. Now I'm going across to page 217, and I'm looking at problem number 59. Well, there's no denominator, but there's a radical. And when there's a radical, the radicand has to be greater than or equal to 0. In other words, I'm saying this thing that's under the radical sign has got to be a positive number. So I solve this inequality by adding 12 and dividing by 3. So x has to be greater than or equal to 4. So my domain is all real numbers greater than or equal to 4. Well, I could write that as from 4 to infinity. I could write it as x such that x is greater than or equal to 4. There's some choices of how that might be expressed. Now I'm going to look at number 63. Well, I've got a denominator and I've got a radical. So normally the radical would be that it has to be greater than or equal to 0. But because it's also in the denominator and a denominator can't be 0, I take off the equal part and just do the greater than. And that's because it's not only under a radical, but it's also a denominator. And I add the 4, and this is my domain. All real numbers greater than 4. I could write it as 4 to infinity with a parenthesis since the 4 is not included. I could write the set of x such that x is greater than 4. Any of those ways would express that. All right, number 65. P of t, and don't let that confuse you. That's just another way of writing. They can use any kind of letter they want to for a function. I guess they got tired of using x. Well, we've got two issues here. We've got a radical and we've got a denominator. That's a 21 in case you can't read that. Well, the radical has to be greater than or equal to 0. The denominator, I have to figure out what makes it equal to 0. So I'm going to add 21 and divide by 3. Well, whatever makes that 0, that's what t cannot be. So it's got to be bigger than 4, but not 7. So what that looks like on a number line is we start at 4, we shade, skip 7, and then keep shading. So as an interval, it would be from 4 to 7, with 7 having a parenthesis, combined with 7 to infinity. That's one choice of how you'd write that. Another possibility is we could write the set of x such that x is greater than or equal to 4 and x does not equal 7. Alright, that finishes the problems from this group, and that finishes the last assignment for the week that's going to end on the 14th.